Hello everybody, I'm back again for another video, and this will be our discussion for the intro to inferential statistics. So in the previous module, in the previous material, it was the descriptive statistics that was talked about. So this will be the continuation of that, but inferential statistics is a bit different. So yeah, let's go. For this topic, we will be continuing our data analysis process. So before, we tried to learn about how data collection should be composed of the stages of randomization, of having repeated measures or having controls, so that it will be the best sample, most representative sample that we can get. And then we tried to describe our data. We tried to organize them in different graphical presentations in as well. For example, bar graph, pie graphs, histograms, and so on. So we also learned how to do it in descriptive statistics. We described the average or the mean, the median, the frequency, and might as well had the standard deviation and the variance. So after all those initial processing, we cannot right away go to this part of drawing conclusions, because there's much more to our data, and that is now going into the window of the realm of probability and statistics, and you will understand later on why we have to do that. So again, for this lesson, we are going to specifically explain the concept of statistical significance and its importance in research. This word, statistical significance, we kept mentioning this term whenever we write our hypothesis in a research paper. For example, what is there a significant difference among this and that? So it has a heavy weight on research as well. We're going to distinguish between type 1 and type 2 errors. There are certain errors that we can commit whenever we make decisions in accepting or not accepting the hypothesis that we made. And as well as we're going to have a review and strengthen our knowledge in writing null and alternative hypothesis. Next to this, we're going to describe how overall inferential statistics work in the research process. And with this knowledge of the whole logic of inferential statistics, we will then make ourselves ready to try on different hypothesis tests. Yes, so review, and then we're going to have this activity, the role of chance activity, which we did in the online class. But I'll just go over this video. Okay, and then the discussion proper, and then the time for your activity. So review first. So far in the previous SLHTs, let's have a short review. So what is this term? That refers to the sum of the data values divided by the number of values in a data set. So the sum of, so you can pause this video, you can answer it by yourself. And so it refers to the sum of the data values divided by the number of values in data set. For example, the data values would be, you have a 3, you have a 4, a 5, and then you add them all. 3 plus 4 is 7 plus 5, and that's 12 divided by how many they are? 3. So 12 divided by 3, that's 4. So 4 is this number that represents the middle of those 3. And for a clue, yes, right, it's the mean. Next, this refers to the element in a data set that occurs most frequently. You have a 3, you have a 4, you have a 5, another 3, another 3, another 3, and then comes 4, a 5, and a 5, and so on. So the most frequent element in this set is 3, and that is the mode. Next, this value is a measure of variation based on how far the data values are from the mean of the whole data set. So how far the data values are. So for example, you have 3 and 4 and 5. And for example, our mean is, or the mean here is 4, the center value. So we have 3 from 4, you just it's 1 unit distance, and 4 to 5 it's 1 unit. So the values have 1 unit interval. So for example, the next one is 6 and 7, and here it's 2 and 1. So 1 unit interval, and that variation is your standard deviation. How far the values are from the mean. So for example, from the mean of 4, 2 is 2 points farther. So that's the general variation. So it doesn't always have to be a whole number, but yeah, you can go back to SLHT4 for this one. And then for this part, I will leave this to you as you read along or review by yourself. Okay, so let's now go to the activity. We did this activity in class, and then it's called Blackpink roulette, but not really. So there's a roulette, and then it's divided into 1, 2, 3, 4, 5, 6, and then it's black, and here is black, and another black, maybe. Sorry. Let's erase for a while. Okay, and then another black, and another black, and then this one would be pink, and this is pink, and this is pink. So equal distances from each other, and then there's a roulette, and then the randomizer would just make it turn, and then I'd ask the students to count in six turns how many blacks has appeared. So in every 6th turn, and out of the activity we had this, the number of times the black word has appeared in 6 roulette turns is this. So observing this bar graph, we can see that there's this general pattern of something like this. So even if we had just a short time, we were able to create this graph out in Google spreadsheets. Yes, and then looking at this one, you see that the 3 times black has appeared is the highest one, and the values seem to form this one. So when you work with a large number of data set, the numbers, continuous numbers, would somehow form a pattern, and this is a distribution called the normal distribution, and this is the basis for how we make decisions in our data. So numbers take the form of a distribution, and then they have this general bell curve pattern called the normal distribution, and this is now the basis for most of our decisions. And for more about this, you can go back to SLHT4. There's a short discussion about this one, but let's continue now on why we are doing this graph. Okay, so just leave it for this picture now. Okay, so before I go further on, let's have some terminologies to remember. In statistics, we have this term called population and sample. So population refers to the total set of observations that can be made. For example, you want to calculate the average height of humans, all humans present on Earth. So the population would be the total number of people that's actually present on Earth, the whole population, everyone from all countries. A sample, on the other hand, is a set of data collected or selected from a predefined procedure. You can have random sampling or purposive sampling, or you can just choose which country you'd count as humans on Earth. So it's a predefined procedure. For our example above, it will be a small group of people selected randomly from some parts of the earth. So to make it not biased, you should just you, as much as possible, try to get a representative sample from all the countries, not just from Philippines or not just from Indonesia and so on. So to draw inferences from a sample by validating a hypothesis, it is necessary that your sample is random. So we must remember the principles of designing the experiment. It has to be randomized. Okay, so another important aspect to understand is this term distribution. Okay, so the distribution of data. When population is infinitely large, it is improbable to validate any hypothesis by calculating the mean value or test parameters on the entire population. We're not able to do that, or can we? Or, well, it would take a lot of time and money to survey all the people. Okay, so in such cases, unless it's a national census or something. Okay, in such cases, a population is assumed to be of some type of distribution. Like, it's a generalized pattern of all the numbers. And in mathematics, they call it these terms here, which we will not cover for now. Okay, so here we go, inferential statistics. So the whole notion of this one, in our data analysis, we have to go to this part really, not just the descriptive statistics. We will not just end there. So the whole notion of inference is based on the assumption that you can actually accurately select a sample in such a way as to maximize this representativeness. Select a sample and make it representative of the whole population, and then infer from it. So the process then becomes an inferential one, wherein you infer from a smaller sample to the larger population based on the results of the tests that you did and the experiments that you conducted using the sample. How will I visualize that one? So how inference work? Turning to your SLHD, page 2. So we have here, how about we go through the steps of a research project, and see how the process of inference might work. For example, a researcher wants to examine whether a significant difference exists between adolescent boys and girls in a way that they solve some moral dilemmas. So here is a sequence of how things might happen. So number 1, the researcher selects a representative sample of adolescent boys and girls in such a way that samples represent the populations from which they're drawn. So from this whole population, they get some participants which they believe are representative samples of their categories. So each participant is then administered a test to assess for this research on the level of moral development, and the scores are organized, and the mean scores for the group of the boys and girls is compared using some statistical test, and then it was analyzed further on, and a conclusion is reached as to whether the difference between the scores is just a result of chance or is it a factor of gender. And so on. So from this whole procedure, we're able to get our insights from this small population, but it's like we're looking at a window to the whole population. So in other words, the inference is based on the results of an analysis of some sample data which is made about the population. Wow. So just a small data, we're able to see what could it be in a population. So yes, because most of the time we can't work with the whole population. So I mentioned also, so after that, let's move on to the next part, the role of chance. In our activity, we had to turn the roulette 6 times, and then we just have to get black or pink or black or pink and so on, and you count them. What if at the turn of the roulette you get green? So what is the reason for that? That could just be chance, right? Or some other reasons. Maybe the roulette was rigged or something. So it is the occurrence of variability that cannot be accounted for by any of the variables that we are studying. Okay, this is why also it could happen. No matter how small, there's always a chance. So that things could be this and that. So in doing our research, we cannot begin with the assumption that the differences that we observe between two things is caused by, for example, X. For example, the differences between the scores of girls and boys is just due to gender. We cannot assume that. So our primary role as a scientist is to design our research well. So to reduce the degree that chance might play in understanding the relationship between variables. How? Well, we have to follow as best as we can the principles of research design. Controls, randomization, repetition, and so on. Okay, so the next concept now touches the activity that we did. So we first have to acquaint ourselves with the different notations that we will be using. So there's this term called population parameter and sample statistic. Population parameter is a value, for example, mean, standard deviation, or size, is a value that is taken from the population. So it's a parameter. In sample statistic is a term for a value that was taken from the mean, from the sample. So when you talk about population values or population parameters, we use this. This is read as mu. So this is sigma, and this capital N. And for this one, X bar, and the standard deviation in some sample statistic for books is that it's S or SD, okay, and so on. And the small n would stand for the sample size. Okay, so just remember these. And then for this concept, central limit theorem. So going back to the whole distribution that we have seen in our bar graphs. So if the sample size of n are drawn at random from any population with a finite mean and standard deviation, the sampling distribution of the sample means X approximate a normal distribution as n increases. What does that mean? As n increases. So the more we do our activity on the roulette activity, the more that we will form this normal curve. So in normal English, if you collect as many samples from an ordinary random variable and calculate the mean of each sample, then the means will be distributed in an approximately bell curve, or the mean of the means, and will be the same as the mean of the population. So the more that we do our samples, the more that we can mirror what it could be actually like in a population. So the larger the size of the samples you collect, the more closely the distribution of their means will approximate a normal distribution. So we can now estimate well. So this is why we are able to use this concept of representative samples in our inferences or in our research. So how can we use the central limit theorem to help us construct a sampling distribution without repeatedly sampling? Because we cannot do as big as a survey, as big census all the time, or we just have to get representative samples. So we use what we know about the population and our proposed sample size to sketch the theoretical sampling distribution. So we will just try, so as much as we can, to make it representative. Other things to remember, so in statistics, they believe that the sample size has to be around 30 or greater, so at least 30. You may assume that your sample would approximate the normal distribution, so regardless of the original distribution of the random variable, and so on. So you can read more about this in our SLHD. And then, so in general, this is perhaps the most important theorem in statistics, the central limit theorem. So it confirms what might be an intuitive truth to you by now, that as you increase the sample size for the random variable, the distribution of the sample means would approximate a normal distribution. So we can use our sample, study about it, and then infer something about the population. And we can compare those with different hypothesis tests. Okay, now, significantly significant. Let's go to the concept of significance. So what does the word significance mean to you? You can pause this video and comment what the word significance mean to you, or you can write in your answer sheet. For now, exercise number 3, you're going to make a concept map on the different words that associate with the word significance. Okay, so while you do that, let's continue. So the concept of significance. Here's this example study. So 2 researchers investigated whether the difference are present between the attitude of adolescents whose mother work and the attitudes of adolescents whose mothers do not work. So to doubt, mothers work and mothers do not work. So let's add the word significant to our discussion of differences, and we have a research hypothesis that's something like this. So hypothesis, there is a significant difference in attitude towards maternal employment between adolescents whose mother work and adolescents whose mothers work. So attitude towards maternal employment. Okay, and so on. Okay, between adolescents whose mother work and adolescents whose mothers do not work. So attitude towards this concept. Okay, so will we just be comparing A versus B? And then just account the differences in attitudes between both? Would it be just simple as that? Well, that could be right. We could be finished. Well, no, not quite. Why? If only we were perfect. Because in this whole paper here, there are many things that could go on. The environment of a single individual, how their values are inculcated to them, and so on. So the different aspects that could influence. So if we cannot observe all of these. So if only we were perfect, that it's just A versus B, but not. So what could go wrong? Well, all of those other things that we cannot account for. Environment, maturity level, or maybe the condition of the person answering the test during that time, and so on. So many things. So there's really that chance that you would get a response that is not related, or that is caused by, or that would be having some error. So there is this concept in statistics, the significance level. So in most research papers, you might see significant findings occurred at the 0.05 level. Well, you will see this probability is lesser than 0.05. So translation. So that could mean there is 1 chance in 20, or 5 in 100, or 0.05, or 5% chance only that any differences found were not due to the hypothesized reason. For example, whether mom works. Okay, so other reasons, for example, all those other factors. So there is just 1 chance that there's an error, or 0.05 level. So you must eliminate all other competing reasons, and then we have to establish this kind of significance level. So in sum and in practice, the researcher defines a level of risk that he or she is willing to take. If the results fall within the region that says this could not have occurred by chance alone, something else is going on, then the researcher knows that the null hypothesis is not the most attractive explanation. So you could reject your null hypothesis and then attribute it for your alternative hypothesis. Instead, the research hypothesis is your favorite explanation. Yeah. So again, there's this concept, significance level. In other books, it's also known as alpha. the measure of the strength of evidence that must be present in your sample. How much evidence do you have against your null hypothesis? Okay, we have this significance level of 0.05, indicating a 5% risk of concluding that a difference exists when actually there's none. Okay, we also have this p-value that we will compare, but we can go back to this later. Okay, other examples. Here's this research. Is there a difference between the academic achievement of children who participated in the preschool program and that of children who did not participate? Okay. So the null hypothesis is that the two groups are equal on each other on some measure of achievement. So the preschool program and those who did not participate to a preschool program. So the research hypothesis or the alternative hypothesis, aka so this is that the mean score of the group of children who participate in the program is higher than the mean score for the group of children who did not participate. So you have this certain claim. So A versus B again. And then you're going to check if there is a difference due to their preschool participation or preschool experience. But then again, it's not that direct. So we still have to make sure that there is this straight causing line. So as much as possible, we collect the data that is representative. We have to make control measures. So in the whole process of statistical inferencing, the purpose of collecting data on a sample is not simply to have a data on that sample. Researchers take the sample in order to infer data from that data some conclusion about a wider population represented by the sample. So even with just whole small sample, we can make this. We will try our best to collect a good sample that would reflect the population, which is a big picture. Okay. So there are different types of statistical inferences. We have estimation and statistical tests. So estimation, we use information from the sample to estimate or predict the parameter of interest. For example, in a presidential poll, so there are different institutions that give out presidential poll to estimate the true current approval rating or to estimate the true current approval rating nationwide of a certain president. So this one. We can also have statistical tests. We are going to use information from the sample to determine whether a certain statement about the parameter of interest is true. Statistical tests are also referred to as hypothesis tests. So this one is more like a reverse. You have a certain claim, and then you are going to test if this one is true. So that's the nature of statistical tests. Or there's a status quo, and then you will test if that is still correct. So for example, the presidential current approval rating is said to be greater than 75%. So you're going to check and do your hypothesis test and use your poll data if this statement is true. So you're going to get a sample survey from a representative group of people and then check if this is true. So that's the nature of statistical tests. So in estimation, we will be using a confidence interval. It is an interval of values computed from a sample that is likely to cover the true parameter of interest. For example, 5%, but lesser, 1% lesser or 1% greater than 5. So around 4 to 6. That's the interval. That's like naturally or literally an estimate. So in hypothesis testing, we will be doing a statistical inference that involves asking a question, collecting data, and then examining if that data would tell us which and which, so telling us how to proceed. So for this lesson, we are going to focus on hypothesis testing. So imagine now that this is like the part 2 of your SLHD. So we had the concept of significance, we had the concept, the role of chance, the central limit theorem, and so on. So to summarize, it just tells us that we must be able to get a representative sample that would enable us to look into it and then tell us about the population, if the population is this or that. So this is done through the process of hypothesis testing. So the first step in hypothesis testing is that to set up two competing hypotheses. So the hypotheses are the most important aspect. We will start with statements that we can test on. So if the hypotheses are incorrect, your conclusion will also be incorrect. So the goal of hypothesis testing is to see if there is enough evidence against the null hypothesis. In other words, to see if there is enough evidence that we would be able to reject the null hypothesis. Hypothesis testing is just surrounding the idea of checking if the null hypothesis is correct or not. So if there is not evidence, then we will fail to reject the null hypothesis. So in this whole logic of hypothesis testing, we want to know the answer to a research question. We determine our null and alternative hypothesis and then make a decision. So the decision is either going to be reject the null hypothesis or fail to reject the null hypothesis. Only those two. So note, why can't we say accept the null? There's this thing called accept the null. So the reason is that we are assuming the null hypothesis is true and trying to see if there is evidence against it. So therefore, the conclusion should just be in terms of rejecting the null. So it's actually incorrect to say accept the null. We're just saying reject the null hypothesis or fail to reject the null hypothesis. Developing null and alternative hypothesis. So let's review null and alternative hypothesis. I hope you still remember about these two. Yes, so null hypothesis, no difference between a hypothesized population mean and sample. The values in the population are just equal to the values in the sample mean that we're looking at. Or this could also be the status quo hypothesis, like there is no difference. So alternative hypothesis, on the other hand, often the hypothesis that we believe or the ones that we want to test. And for example, we were to test the hypothesis that college freshmen study 20 hours per week. So how should we say this one? For example, college freshmen study 20 hours per week. So our population is the college freshman, and then it says that it studies for 20 hours per week. So the mean of the population is equal to 20 hours. So that is our null hypothesis. But then H sub A, so null would be H sub O or HO or H null, and then this one is H1 or HA, and so on. Just H sub A or HA. So for our study, we will be using these two notations. Null hypothesis, and the alternative would be that it is not equal to 20 hours. So we have learned how to write this one in sentences when we were in the first quarter, and now let us try to use these kinds of notations. So another example, we have a medicine that is being manufactured, and each pill is supposed to have 14 milligrams of the active ingredient. What are our null and alternative hypotheses? Okay, so medicine manufactured, each pill is claimed to have 14 milligrams. So the population of pills is that the mean weight of a certain active ingredient is equal to 14 milligrams. And then we'd like to check if it is not actually 14 milligrams per active ingredient. Okay. So our null hypothesis states that the population has a mean equal to, no, not this one, it's a wrong, 14 milligrams of weight, and so on. So there are other common phrases that we can use, and then I've placed this one in your SLHT 6. For example, is greater than is this symbol, is less than, then things like is greater than or equal to. So you will be checking this one in the statements and then which ones to use. Okay, so the most common ones would be is equal to and is not equal to, or has not changed or has changed. Okay, so in the whole process of hypothesis testing, we're going to check what is the difference between the hypothesized population mean and the mean of the sample. So you're going to get the hypothesized mean of the population and the calculated mean of the sample. You are going to compare them, and then you will check if there is a small difference or a large difference. If there is a small difference, you will fail to reject the null hypothesis, and if there is a large difference, you will reject the null hypothesis. Okay, so there is this concept also of critical value, and let's go to this one. Okay, in the concept of critical values, there is, for the whole distribution of data, there is this area called critical region, and then this is bounded by a critical value, and that 95% of all the values here are said to happen accordingly. So it just agrees with the null. So do not reject the null if a certain test value appears here. But if it falls here, then we are going to reject the null, and so on. So there are also types of these kinds of tests, but just remember that there is this only concept of critical value for most of the hypothesis tests that we will be doing. So critical values can be used to do hypothesis testing in the following way. We're going to calculate a certain test statistic. Maybe we can do t-test or analysis of variance, an f-value, and so on. Then we are going to calculate the boundary value or the critical value based on our significance level, the alpha. And then just compare. If the test statistic is lower, accept the null hypothesis, or else reject, and so on. So we have to have these rules. We will just discuss this one in detail in the next SLHTs. Okay, so the things that you have to learn are, for this one, there are two types of hypothesis tests: the two-tailed test and the one-tailed. So two tails, this one. So remember for example, the alternative hypothesis would be not equal to something. So this. If it's not equal, there are two tails. So if the sample mean taken from the population falls within these critical regions in here, we would conclude that there was too much of a difference and we would reject the null hypothesis. However, if the mean from the sample falls in the middle of the distribution, in between the critical region, we would fail to reject the null hypothesis. So for example, not equal to 14 milligrams. So all of the regions here tells us the probability that it is just equal to 14 milligrams. But it could be, there's a chance that it is lesser than 14 milligrams, for example, or there's a chance that it's largely greater than 14 milligrams. Maybe a certain 20 milligram, or here is just 1 milligram, and so on. So two-tailed test, because you just mentioned that it is not equal, so it can be at the lower end or at the higher end. Okay, so two-tailed test, for example, But now let's go to one-tailed hypothesis test. So in the two-tailed, you did not give a side like blank is great, should be greater, should be lesser, and so on. You just said it is not equal. So no non-directional. But you could actually also do the one that chooses a direction. For example, your null hypothesis is that mean population, a certain population has this mean that is lesser than or equal to 1,100, but you want to claim that it is actually the mean population that is greater than 1,100. So it's not lesser, but it's actually greater. So you said a certain side, so greater. So it is called a one-tailed hypothesis now when you are choosing a side. So greater side or the lower side. So this is now a single-tailed hypothesis when the direction of the results is expected and we are only interested in one direction of a result. For example, we are trying to check if it is greater than 1,100. So if you want to check the greater side, it would be this tail and so on. So for example, a single-tailed hypothesis test may be used when evaluating whether to adopt or not adopt a new textbook, and we would only decide to adopt a textbook if it improved the student achievement relative to the old textbook. So if we would see a greater change in the scores of the students using a new textbook, so greater, so it's now we are doing this one-tailed hypothesis test wherein we will check if the value exceeds our critical value at this end of the curve. Okay, so we will use symbols of greater than or less than. Okay, so for example, another one. Let's say that we're claiming that the average SAT score, there's a certain test that they have to take, and then the average SAT score was greater than 1,110. Remember, our own personal hypothesis is the alternative hypothesis. So we want to check if the mean is greater than 1,110. So that means in the null hypothesis it is not. So the mean is just lesser or equal to 110. Okay, just like this. So to check, we will just look at this region. If a certain hypothesis test will give us a value that will fall in this region, then we can conclude that there is evidence that we can reject the null hypothesis and so on. We have this left-tailed if we're expecting on the lower end, or a right-tailed. So this one is again. My pen is not working. There. Left-tailed. Right-tailed. Okay, so example. Oh, we missed this part here. So before we answer this one, let's have these concepts first. So there are different types of errors that we can commit because we are making decisions. Either we can make a right decision or the wrong one. So here, let's start with the correct decisions first. So if the null hypothesis is incorrect or it is false, and then we rejected the null, so we made a correct decision because it's false. And if the null is true and then we do not reject it, then it is correct. But now, if the null hypothesis is true but we rejected it, so this is now called the type 1 error. So if we also make a decision that is do not reject the null hypothesis when it is actually false. So we believe the null hypothesis, but actually it is false, so it is also wrong. So type 1 error. Type 2 error. Type 1, sakto ang null hypothesis pero ato siyang gi-reject. Type 2 is that sayop ang null hypothesis pero ato siyang gidawat. This one. Type 2 error. So let's have this example. A man, Mr. Redblock, goes to the trial and is tried for the murder of his ex-wife. He is either guilty or not guilty. So the null hypothesis in sentence form, how would that be? So Mr. Redblock is guilty or not guilty. So the answer would be null hypothesis. So we have to assume that he is innocent. Mr. Redblock is not guilty, so innocent, not guilty, and so on. But then number 1. Number 2, give the alternative hypothesis. So first, alternative hypothesis would be Mr. Redblock is, for example, we would choose that Mr. Redblock is guilty. Next, when the court gives decisions or gives a verdict for Mr. Redblock, what verdict and situation will make it a type 1 error? Type 1 error is that we will accept the type 1 error is that we reject the null hypothesis when it is actually true. So type 1 error would be committed if, try to pause this video. So type 1 error is committed when the null hypothesis is true, but then it is rejected. So null hypothesis is true. Mr. Redblock is innocent, but we rejected it. So the type 1 error would be, we would say that he is not innocent. Not innocent. When he is actually, innocent. Type 2 is saying that the type 2 would be the null is false, but we do not reject it. So null is false, so not innocent. He is actually not innocent, but we said, but we just say he is. He is. So we said that we accepted the null hypothesis. So accepted the null. So if you accept the null when he is actually not innocent, so na kuan na nasayop na gihapon. Okay, so how would it be a correct decision if we can correctly say that he is innocent when he is actually innocent, or guilty when he is actually guilty, and like that. Okay, so the type 1 error is like putting an innocent man in jail because he is so it could be possible that we could put an innocent man in jail. So we would say that he is not innocent when he is actually innocent. So that is very, very heavy, right? So it is hard. So ethically very heavy. So it is some serious charge to put an innocent man in jail even if he is not guilty. So it is better to minimize the probability of a type 1 error, and then we will choose a smaller significance level in our research. So that's just the main concept of hypothesis testing: null hypothesis and then alternative hypothesis, and then we will check if the null hypothesis could be rejected or can we not reject it. And then there's the small chance of error, so we will set our boundaries and make it as small as possible to make an error, to make a small chance of sending that innocent man to jail. So we call that the level of significance. So we will then follow the different tests that we can have, such as this one. So if, for example, if a research question is asking for a difference, then we can have two groups or one group. So we can do all these kinds of tests and so on. So if there's a relationship in this one, okay, then you just go over this part in your SLHT. It's very easy to see in this diagram, so just read over. So to summarize everything, part 1 was the whole concept of chance and then of significance, of establishing a representative sample, and part 2 was the whole logic of hypothesis testing, and that there are two types of tests that we can have, like two-tailed test, no direction, that you can say blank could be not equal, so it could be lesser or greater than. And then in a one-tailed, this is the kind of test that you were trying to check if blank is actually greater or blank is actually lesser, so one-tailed. And then we also had the type 1 and type 2 error. Type 1 error is when we check, when we believe that the null hypothesis is correct, but we rejected it. And then type 2 error is when the null hypothesis is false, and then we will not reject it. So overall, hypothesis testing involves making an educated guess about a population based on a sample that we got from the population. So the sample would be our window to the population. We then generate our null and alternative hypothesis based on the mean of the population and test these guesses. So in other types of tests, it is not just the mean, we can also have standard deviation and variance and so on. So next, we will then establish a certain region where we can say that we have to reject or we have to not reject the null hypothesis, and this is called the critical region, and it is based on our level of significance or the alpha. So in most books, this one is established as 0.05 level, or in medical studies it would be 0.01. We will just be more specific about this as we go on to the different hypothesis tests. So if the value of the certain test statistics falls in a critical region, we can reject the null hypothesis. And lastly, when we make a decision about a hypothesis, there are 4 different outcomes and possibilities, and the 2 different types of error, as mentioned, the type 1 and the type 2 error. So that's just the whole coverage for our SLHT number 6. So in summary, we make decisions in everyday life, right? When we wake up, unsay mong pilion, matulog ba kag balik or maligo na kag sayo kay kailangan na ka mag-start. So in everyday life, we often have to make decisions based on incomplete information. We really don't know what's going to happen next, but we have to decide. So just like in hypothesis testing. So let's still do our best, and then let's try to do as much as we can and own our decisions. So that's it, own our decisions. Unsa imong napili, mao na imong barugan. So own your decisions and show up. So that's it, and then pwede na ninyo i-ansiran inyong activity. Okay, so I think for questions, you can still message me in my teacher account. Again, show up. Okay, so nice to see you everyone, and thanks for watching up to this part of the video. I know it has been long, but I hope that you got a few things or more in this video, and see you in the next video. Goodbye.